So we've got a little example here where we're trying to find the power when we have these variables provided. The example would be, for instance, moving a box, and you apply a force of some sort to push that, and you push it through a distance of 100 meters. We've been told the mass of the box is 10 kilograms and it accelerates at 2 meters per second for the duration of that 100 meters. A little bit unrealistic, but we'll get the principles across. And remember, we're aiming for the power here. So to start us off, we need to know this force. Okay, the force applied. Maybe I should step this back. Power, which we're aiming for ultimately, is the amount of work done over time. Work done is the energy converted. So when you're converting energy, you're doing work. That's where the concept of work comes from. Work is also the force times by the distance. So we apply a force here during this distance, and that can tell us the amount of energy converted. But, so we've got a third step. To know the force, we need Newton's second law. Force is mass times acceleration. Now, if we wanted to make this just a little bit sort of, I don't know, I like stepping through the chains from here to here to here, or in reverse in our case. You can either do it that way, where you calculate the force and then substitute the force in there, and then calculate the work and substitute the work in there, or you can put all these into one equation. So for your work equation, you've got work as force times distance. You can substitute mass times acceleration times by the distance, because the mass times acceleration is the force bit. And then again, you can substitute this into the power equation. So you have power as work over time. The work in this case is mass times acceleration times distance over time. So this makes it a little bit easier. You do less calculations and less steps in the calculations, but it may not communicate the understanding as well, or you might not understand why you've done what you've done. But let's calculate it anyway. The mass was 10 kilograms. The acceleration was, let's double check, I think 2 meters, yes, 2 meters per second. The distance moved through was 100 meters, and the time it took was 120 seconds. So if we were to plug all of that into a calculator, we would have 2000, if you're doing a calculator, divided by 120, which again equals, that's going to cancel, we've got 200 divided by 12, or 20 divided by 1.2. We'll just plug that into a calculator, I think, and we end up with 16.6, and the 6 is recurring, so let's round it to 7, 6.67 joules of energy per second, or watts. So we might round that. I haven't been too particular with significant figures, but let's just say that the answer in this case is 17 watts, rounding it to 2SF, just for the sake of a tidy answer. So just stepping through that again, we had the question provided to us, we had the information provided, and we are converting energy in a person who's pushing this block. They apply a particular force based upon the mass size and the acceleration how they're accelerating it. And oh, I've got a little alarm going off in the background. Where do we get up to? So they're applying a force. That force is applied for a certain amount of time over a certain distance, which gives rise to the work done over time, which is the power. And we can make the equations into one equation by substituting the equivalent parts in, and using one equation we just do a single calculation to find the answer.